In this video, I'm going to solve a third problem under the orthogonality condition. In a previous video, means in the last 4 videos, you people have learned about the totally 2 problems. One is the finding the angle between the surfaces, another one is the finding the angle between the normals here. This is the third problem that is under the orthogonality here. So see here what we have a statement of the problem. Find the value of the constants a and b such that the surfaces ax square minus byz is equals to a plus 2 of x and 4x square y plus z cube is equals to 4 are orthogonal at the point 1 comma minus 1 comma 2. So observe here in this problem, what is our aim here? We have to find the value of a and b. We have to find here value of the constants a and b. What they given here? They given a two surface equations. One is this one, another one is this one. So what they given another one condition? These two are orthogonal at this point. These two surfaces are orthogonal at this point. By using this condition, we are going to find the value of a and b. Observe here, if these two surfaces are orthogonal at this point, then the point must be lies on these two surfaces. So, by substituting this value, means by substituting this point in the first equation, you will get the result of a or a b. Okay, second point, applying orthogonality condition to these two surfaces, you will get the result of another one constant a or b. Okay, so what they given here, just write down. Given phi 1 of x comma y comma z. Consider first surface equation as a phi 1, second surface equation as a phi 2. What they given here? Phi 1 of x comma y comma z, ax square minus byz transpose a plus 2 of x on a RHS side, then it becomes LHS side, then it becomes minus of a plus 2 of x, that is equals to 0. This implies phi 1 is equals to ax square minus byz minus of a plus 2 of x. Similarly, given second one, what they given here? Phi 2. Phi 2 of x comma y comma z is equals to 4x square y plus z cube equals to 4. So this is in the form of phi 2 of x comma y comma z is equals to c2. So this implies phi 2 is equals to 4x square y plus z cube. Okay, these two are the given surface equation. So here by substituting 1 comma minus 1 comma 2 in a phi 1. Okay, substitute 1 comma minus 1 comma 2 in a phi 1. So what they given here? Ax square minus byz minus a plus 2 of x is equals to 0. Okay, substitute wherever is x, y, z, substitute 1 minus 1, 2. So a minus b into y value 1, x value 1, 1 square 1. So b value minus 1, z value 2 minus a plus 2 of a 1, that is equals to 0. So what it implies? Minus into minus plus 2b minus a minus into plus minus 2, that is equals to 0. Plus a minus a get cancelled. 2b is equals to transpose minus 2 on a RHS side, then it becomes plus 2. b is equals to 2 by 2 means 1. So we got here b value by substituting 1 comma minus 1 comma 2 in a equation, means surface equation 1. Okay, similarly you can verify the point with the second surface equation. Substitute in place of a x as a 1 square means 1, y value minus 1, 4 into minus 1 minus 4 plus z value 2 is there. Z value what we have here? 2 cube means 8 minus 4 plus the b value. So we are going to find the value of a. So for that one we have to apply here orthogonality condition, because they given clearly the given two surfaces are orthogonal, then we have to apply that one here. So what we have here? Del phi 1 dot product with del phi 2 is equals to 0. This is the orthogonality condition. I explained this one in a previous note. Okay, so this is the condition you have to remember. Okay, so for the condition del phi 1 dot product with del phi 2 is equals to 0, here we need the parameter del phi 1 and del phi 2. So find here del phi 1. Del phi 1 means that is the definition of a gradient function with a phi 1. So dou phi 1 by dou x into I plus dou phi 1 by dou y into j plus dou phi 1 by dou z into k. So we have a phi 1. So phi 1 means this one. ax square minus byz minus of a plus 2 of x. Just substitute wherever is 5 1, so substitute that value here. I substituted here. So a plus 2 of x into k. Means in place of a phi 1 substitute. Keep all the terms as it is. Then del phi 1 is equals to dou by dou x of this whole function. We have to keep a y and z as a constant. Okay. So ax square is the differentiation of ax square 2ax. byz totally constant 0. Here a plus 2 of x is a plus 2 constant. X with respect to x means 1. 1 into a plus 2 minus of a plus 2. Okay. Into I. Plus dou by dou I of this whole term. Ax square is a constant. This is also constant. Byz is there. Here b and z is a constant. Y with respect to y means 1. Then it becomes minus bz into j. Plus with respect to z is there, we have to consider x and y constant. Here this is constant. Here this is also constant. Minus byz with respect to z becomes minus by only into k. So just rearrange the terms here. 2ax minus of a plus 2 into I plus into minus minus bz into j plus into minus minus by into vector k. Okay, so here only find here del phi 1 value at the given point. What they given here 1 comma minus 1 comma 2 is there na. So find here only 1 comma minus 1 comma 2. Means wherever is x y z in this equation substitute 1 minus 1 2 respectively. So here substitute x means 1 2a into 1 2a minus a plus 2 plus into minus minus 2. Okay, into vector I minus z value 2 is it. So 2bj minus y value minus 1 is there. Minus into minus plus bk. Just rearrange the terms here. 2a minus a minus 2 of I minus 2bj plus b into vector k.